Good morning, students. In the last lecture, we discussed about regular false method and their question. Now, in this lecture, we will discuss about the secant method and the Newton-Rapshan method. And in the next lecture, after this lecture, we will discuss about the secant method and the Newton-Rapshan's method question. Then, after this method, our first chapter will be finished and the methods will be finished. Okay, then today we will discuss about the seeking method. As you know, we have discussed about this. The seeking method, as we discussed, as discussed in regular falsy method, the consequence which results from having the calculated approximation xk on the same side of the root is that convergence may be slow. This is avoided in the secant method. Secant method resembles a regular falsy method that no attempt is made to ensure that the root epsilon is enclosed between two approximations. And these two approximations are we are starting with the two approximations, starting with two initial approximations x naught and x1 to the root epsilon. The further approximation x2, x3 and so on are computed using the following formula, that is x k plus 1 x k minus 1 f of x k minus x k f of x k minus 1 then upon f of x k minus f of x k minus 1, where k is 1 2 3 so on. We have put it equation number 1, or we can write it as x k plus 1 x k minus x k minus x k minus 1 upon f of xk minus f of xk minus 1 into f of xk. We have simply rearranged it and simply further simplify it, and k is 1 2 3 so on up to n, and we have put it equation number 2, where xk minus and xk are two previous most recent approximation to the root. Okay, we no longer have ensured convergence, but the process is simple, as a sign of f of k xk plus 1 is not tested and often convergence faster. The secant method is shown. We have shown it graphically also. We have shown it graphically also. So here we will show here graphically. So check it here graphically. So the secant method is shown graphically in this figure 1, which the successive points where the secant lines intersect the x-axis are denoted by x2 and x3. Okay, then this is the secant lines which are denoted by x2 and x3. And then we have discussed about order of convergence. In the exam, order of convergence will be asked many a time, so this is important. Let us assume that epsilon is a simple root of equation f of x equal to 0. The general iterative formula for secant method is what? This xk plus 1 is equals to xk minus xk minus 1 upon f of xk minus f of xk minus 1 into f of xk, which we have given the equation number 3 in previous. If ek minus 1 comma ek and ek plus 1 are the errors in the approximation, then xk minus 1 and xk plus 1 respectively, then we have the errors in these equations ek minus 1, ek and ek plus 1. Then ek minus 1 is equals to xk minus 1 minus epsilon, and ek is equals to xk minus epsilon, and ek plus 1 is equals to xk plus 1 minus epsilon. That is xk equals to epsilon plus ek minus 1 is equals to xk equals to epsilon plus ek, and xk plus 1 is equals to epsilon plus ek plus 1. Then we have substituting these values. We have substituting these values in formula 3. After the we have substituting these values, we get after simplification this. So expanding by Taylor series, टेलर सीरीज से इसको एक्सपेंड करेंगे एंड एफ ऑफ एप्सिलॉन को हम 0 पुट करेंगे इक्वेशन 4 में, जिसको हमने पुट किया है इक्वेशन 4. आफ्टर ई के प्लस 1, आफ्टर पुटिंग we have to simplify it. After rearranging, we get this. Now we have, by dividing numerator and denominator of second term on right hand side of y, f dash epsilon is not equal to 0. So 0, we have this. After dividing, we get this. Then using binomial theorem for any index plus terms having higher order of errors, and this is the error. And this is the neglecting the terms. Thus we see that, which may be expressed in mathematical notation as this ek is directly proportional to ek minus 1. We have given this equation number 5. Okay, we have given this equation number 5. After that, आपसे जो है एग्जाम में ऑर्डर ऑफ कन्वर्जेंस पूछेगा. लास्टली जो हमारे पास रिजल्ट आएगा वो ऑर्डर ऑफ कन्वर्जेंस होगा. आपको प्रूव करने नहीं आएगा एग्जाम में कि प्रूव करो आप ऑर्डर ऑफ कन्वर्जेंस. या तो आपको या तो आपको सेकेंड मेथड का मेथड लिखने आएगा कि मेथड क्या है. जनरल जो मेथड था शुरू में वो है मेथड इसका, और ऑर्डर ऑफ कन्वर्जेंस का सिर्फ आपको फॉर्मूला लिखने आएगा. ठीक है, ऑर्डर ऑफ कन्वर्जेंस का हमने फॉर्मूला लिखना है. ठीक है, इन द एमसीक्यूज में आ सकता है, 1 मार्क में आ सकता है. ऑर्डर ऑफ कन्वर्जेंस आपको लिखने 2 मार्क्स में आ सकता है. ये डिपेंड करेगा कि कितने मार्क्स में पूछा गया है. ठीक है, सो we know that the order of convergence of an iterative process is p if ek plus 1 is directly proportional to ek raised to power p, or ek is directly proportional to ek minus 1 raised to power p by changing k to k minus 1. We have changed this k to k minus 1. Now combining equation 6 and 7, we have ek plus 1 is directly proportional to ek minus 1 raised power p square. Substituting for ek and ek plus 1 from 7, 8 and 5, we have 7, 8 and 5. अब ये हमारी यहाँ सेवंथ इक्वेशन है, this one equation number 7, this one the equation number 8, and this one is the equation number 6. In previous we have write the equation number 5. Then after substituting, we have ek minus 1 raised to power p square directly proportional to ek minus 1 raised to power p dot ek minus 1. After this we getting this, because these are same, we are taking it common. Now we are comparing the powers, because powers are same, then we can compare it. So p square is equals to p plus 1, that will p square minus p minus 1 equals to 0, and after simplifying we get p is equals to 1 plus or minus under root 5 over 2. Since p is always positive, so we neglect the negative value. So p is 1 plus under root 5 over 2, which is approximately equal to 1.6818. So order of convergence of the secant method is 1.618, which sometimes referred to as superlinear convergence. कुछ टाइम में इसको सुपरलिनियर कन्वर्जेंस भी कहा जाता है. ओके. And the speed of convergence of secant method is faster than the of bisection and regular falsi method. Okay. Next हमारे पास न्यूटन रैप्सन मेथड है. So Newton Raphson method, it is the one of the fastest method in all of these methods. So the Newton Raphson method is a process of determination of real root of an equation f of x equals to 0, given just one point close to the desired, just one point close to the desired root. Okay. So procedure, we have going with the procedure. Let x naught be denote the approximate value of the root nonlinear equation of f of x equal to 0, and let h be the difference between the exact value and approximate value of x naught of the root. Then h is equal to epsilon minus x naught, or epsilon is equals to x naught plus h. After that, so similarly starting with the approximation x1, a vector approximation to the root is given by x2 equals to x1 minus f of x1 f dash x1. So by repetition of the above procedure, we can obtain a sequence of approximation x0 minus x1 x2 such that each approximation is better estimate of the root epsilon than the previous one. In general, starting with the approximation xk, the next approximation xk plus is given by xk plus 1 is equals to xk minus f of xk upon f dash xk, where k is 0, 1, 2, 3, so on. We have given this equation number 3. And then The formula 3 is called Newton-Raphson formula or Newton-iterative formula. The procedure developed above the formula 3 is called Newton-Raphson formula or Newton's iterative formula. The procedure developed above is called the Newton's-Raphson iterative method or Newton's method of tangents. You can call this as you which you can call it as your choice. After that, we have geometrical interpretation. We have geometrical. Then you can see this. This is the proof of this and geometrical interpretation. After geometrical interpretation, this is the you can do yourself. This you have to only learn the result, and important is for you order of convergence. You have to do the order of convergence. So I will explain you the order of convergence. So let us assume that epsilon is a simple root of equation f of x equal to 0. The general iteration formula for reduction method is xk plus 1 is equals to xk minus f of xk f dash xk. If ek and ek plus 1 are the errors in approximation xk and xk plus 1 respectively, then we have put these values in this. Studying these values in equation 6. This is the equation 6. After ek plus 1, this is the next ek plus 1. Then this is about e using z. Expanding this. After expanding this, we have at lastly this, and we'll go to this space. You can see that this is the after using this we have get the equation Newton-Raphson so second order convergent, and in the examination in the 2 marks advantages and drawbacks are also asked from the examiner. So the advantages of Newton-Raphson method is the Newton-Raphson method is best known procedure for finding the roots of an equation. It has been generalized in many ways for solution other more difficult nonlinear problems. Example, nonlinear system and nonlinear differential and integral equations. The second order of convergence of this method is 2, which makes it fast as compared to other methods. So this method is first preference in attempting to solve a non equation. This method is easy for implementation on computer. It is clear from the formula, the greater the numerical value of the derivative f dash x, the smaller is the correction that must be applied to get the correct value of the root. If the sketch of the curve y is equal to f of x is nearly vertical when it crosses the x-axis, the correct value of the root can be found with great speed and a little labor. And the drawbacks of this Newton-Raphson method is this method is not applicable to solve the equation whose sketch is nearly horizontal when it crosses the x-axis as it would make f dash x equal to 0. So in that case, the method fails. The method is very sensitive to the choice of initial approximation. If the initial approximation is not properly selected, then this method can fall in an endless loop and might even fail altogether in some cases. This method requires two function evaluation per iteration. That is, we have to evaluate the value of f of x and f dash x at each step. So the computation per iteration is more as compared to other method. This method is difficult to apply when the derivative of f of x is not simple expression. And the end of the class. Thank you. Have a nice day. If you have any query, write in the comments. Thank you very much. In the next class, we will discuss about their questions. Thank you very much.